Hello, this is the solution to C++ Challenge 1 Momentum. Last time we left off on this problem of momentum, you were given this equation, mass 1 velocity 1 plus mass 2 velocity 2 equals the final velocity multiplied by the sum of the masses. We are going to simplify this equation into its simplest form and then use it to check our solution using C++. First, we want our final velocity to be all by itself. So we're going to say VF equals mass 1 V1 plus mass 2 V2 mass 2 V2 all over the sum of the masses. I apologize, that's my watch. So this should look like a final equation, correct? Almost. We know that puck 2 is stationary, which means it's staying in place at phase 1. So we know that the velocity of the puck is 0. If the velocity of the puck is 0, then the entire mass of the puck is 0, or it does not matter what it is. So that actually simplifies our equation more to say that the final velocity is the product of the velocity and the mass of puck 1 are divided by mass 1 plus mass 2. Now, let's program our results using C++ to check to see if we did our calculations correctly. Before you move on, if you have not coded any of this, go ahead and try and code what would it look like to ask for an input. Go ahead and try it, and then we'll come back together and we'll look at our first programming language together. Program together. I apologize. Alright, so first let's go into basically how to write this program. And I already have written it for you if you got confused or stuck. So let's open momentum.cpp. That's what I called it. Let's open it and let's see what we did or what you should have done. So first, you know the first 2 lines of every piece of code is include IOStream and using namespace std. Then in your main function, you're going to create 4 doubles. A double for mass 1, velocity 1, mass 2, and final velocity. Then you are going to prompt or ask the user for each of the three variables that they are going to enter: mass 1, velocity 1, and mass 2. I did it in a sort of confusing way. I apologize. And then what you're going to do is you're going to calculate the equation that we found out in the previous section of this video. You're going to use that equation and assign that value to final velocity. Then you are going to see out the final velocity in a statement like this. Writing code like this is actually very beneficial to most people, because by doing this, you're writing great code for user interface. You aren't writing vague code. You're writing code for the people to use. That's what we all want, basically. We want to create user-friendly code. Let's see how this code runs, and if it runs correctly, like mine, then we are good to go with this project. So, make sure they're G++, make sure there aren't any errors, and then simply a.out it. It's going to ask you for the velocity of puck 1, or in some cases the mass. So keep track of what you're putting in. Let's do 5, 5, 10. To repeat, the mass of the puck is 5. The mass of the puck 1 is 5. The velocity of puck 1 is 5. And the mass of puck 2 is 10. Don't worry about units. I know that in my previous video, I put a big emphasis on units. Just worry about getting the correct equation. You should get the final velocity of the puck after the collision is 1.6667, or 5/3. And in fact, that is true if you actually do the calculation. Let's do one more just to be 100% sure you got it right. Let's try 9 for the velocity, 87 for the mass, and 6 for the mass. You should get a final velocity of 8.41935 if the mass of the puck 1 is 87, the velocity is 9, and the mass of puck 2 is 6. I hope this helps a lot, and I hope you are able to understand what we did here in our first project. Thank you so much for watching, and I will be out with more videos again every Wednesday until the end of the summer. If you have any questions or concerns regarding this video or any of my previous videos, make sure to leave a comment down below or contact me through any of my social medias linked down in the description. I'll see you guys in the next video. Bye.